Hey guys, this is section 13.2 on absolute value functions and transformations. You should have the notes already in front of you so that you can get started on this. So make sure you have the notes in front of you. Let's get started. First things first, we're going to highlight our essential question like we always do. It says, what are the effects of the parameter changes on the graph of y equals a times the absolute value of x minus h plus k? So what that means is that there's going to be some changes to an equation that looks like this. We're going to change some things that we call the parameters, which is really the h, the k, and the a values to see what happens to the graph. Okay, so let's start with the first part where it says the most basic absolute value function. Let's start there. So from previous classes, previous experience, you guys are familiar with absolute value. Okay, what absolute value does, it looks like this, right? Like two bars, is it makes everything positive. You put something in there and it turns it positive. If it starts being positive, then it's still positive at the end. Okay, it does not change anything to a negative. Really, an absolute value function is a piecewise function, right? Something that we have been looking at this week. A piecewise function that looks like this. So it's x if x is greater than or equal to 0, and it's negative x if x is less than 0. So it's called the parent absolute value function. This one right here is the parent absolute value function because it's the most basic one of all. We're going to graph this one real quick. I believe I showed you guys how to graph it really easily in class, but let me show you guys how to do it with the table so you guys can see where that graph came from. So if you notice here, I did what we always do with piecewise functions. I split them up into two tables. So x is greater than or equal to 0 is for that one, and x is less than 0 is for this one right here. And x is greater than or equal to 0, what I did is I put an x right there, and for this one I put negative x right there, right? So using this as my guidance, I am going to choose some points that I can plug in. For example, since I want values that are greater than or equal to 0, I'm going to start with 0. There you go, I fixed it. I'm going to start with 0. And then I'm going to choose some values that fit the requirement, which are numbers that are greater than or equal to 0, like 1 and 2, and you could keep going, 3, 4, and so on. I am plugging in those numbers into this, which is the exact same thing that I'm starting with, right? So I should get the exact same thing back. So 0 gives me 0, 1 gives me 1, let's fix that, and 2 gives me 2. And we're done with that table. Let's actually graph it already. I have a graph over here on the right side. So I'm graphing 0, 0. Make this one in blue. Right there. Oh, you know what? Let me erase that and check. Remember to always check if it's supposed to be open or closed. Look at this one. Since the first one I'm graphing is this point, 0, 0. Then I need to check open or closed. You guys see the little equal sign underneath? That one is closed. So actually I had got it right the first time. So you should have a closed circle right there on the origin. Then 1, 1 is right there. Put a point there. And then 2, 2. It's right there. And it keeps going, right? Look, it says x is greater than or equal to 0. So I could keep this going, which means that when I connect them, I could draw an arrow on that side to show that it keeps going. It does not keep going on this side because of the closed circle right there. Alright, let's do the other table. For the other table, we want values that are less than 0. So I'm going to start with 0 just like the other one, right? You always start with that number. And then numbers that are less than that. So negative 1 and negative 2. And you could keep going. But I only left 3 spaces, so we could have a good idea with only those numbers. So if we plug in 0, we're plugging it into this. We're going to get 0. If we plug in negative 1 into negative x, think about this carefully. You have negative, and then plug in negative 1. So what you have is negative, negative 1, which becomes positive 1. Plug in negative 2, and the same thing's going to happen. Negative, negative 2 becomes positive 2. So those are your actual values for the table. Let's graph those numbers, those points, I mean. So 0, 0 is right there on the origin again. Now this one, it says x is less than 0, so it should be an open circle at 0, 0. So I should put an open circle right here. But there is already a closed circle on that exact same spot. Basically, what happens when they overlap is that closed wins. There's a closed on top of an open, or an open on top of a closed. Closed wins. It ends up being that it's just a closed circle because of the other one that was already there. Plug in, find negative 1, 1. Let's plot that one. Plot negative 2, 2. And once again, it keeps going on the left side, right? Negative 3, negative 4, negative 5, and so on. So it's going to keep going on this direction. So when you connect them, keep them going that way. And put an arrow at the end. It does not keep going to the right because of the circle, the open circle, which is really a closed circle. And that's what the parent absolute value function looks like. Okay, basically what it does is it's a piecewise function. It breaks up your function into two pieces. On one side it looks like this, and on the other side it looks like that. Okay, but they're basically perfect reflections of each other. The two sides are perfect reflections of each other. But really, the way we're going to graph it the fastest way is to put a point at the origin and then just use the slope of 1. It has a perfect slope of 1, which means it goes up 1 over 1, up 1 over 1, up 1 over 1. And on the other side is the exact opposite. Instead of up 1 over 1, it's up 1, left 1, up 1, left 1. So you could have a mirror image, right? They're perfect reflections of each other. All right, let's apply that to example number 1. So number 1 says, graph each absolute value function with the parent function f of x equals absolute value of x. So let's start by graphing this, just like the one that we just did. Okay, so you can actually take the graph that we just did above and draw it here. But I'm going to show you guys how you can easily graph it every single time I give you this. Okay, so whenever they tell you graph the function with the parent function, that means graph this one, and it's really easy to graph. All you got to do is first start by putting a point at the origin, because the parent function always passes through the origin. And then use what I told you about the perfect slope. It has a perfect slope of 1. So that means up 1 over 1, up 1 over 1. So from that point at the origin, go up 1 over 1 to make your other points like this. And on the left side of the origin, you do the exact opposite. Instead of up and to the right, go up and to the left. Up and to the left to get that perfect reflection. It's like a mirror image, right? It's symmetrical. And then you draw lines with arrows going to the left and to the right. And that's basically the parent function. Now all you have to worry about is graphing this one right here. Okay. Now for this one, I'm going to show you guys a couple of things that's going to make it very, very easy to graph. Okay. First of all, you got to notice that it no longer looks like the parent function. It's been changed by adding a 3 here inside the absolute value and subtracting a 5 outside the absolute value. Okay. Each of those two numbers has a name for it, a variable that we use for it. Each one of these two is called what we call a parameter. Okay. H is always the one inside of the absolute value. The way I like to think of it is that H is the homie of X. That's why it's inside with it. But K is not, so K got kicked out. This guy got kicked out. This guy's the homie, so he's inside. So that's how I remember which one is which. H is inside the absolute value. K is outside the absolute value. So if you remember it that way, then it's very easy to see that negative 3 would be the H, would determine the H value, and K would be determined by negative 5. Here's the thing about H though. It's always the opposite sign of whatever you see. So if you see X plus 3, that means that H is not 3, it's negative 3. I like to think of it as this guy's the homie, but when I kick him out, when I pull him out so I could write it here, it changes. It becomes negative, right? So now it's negative 3 because I pulled it out to write it right here. This one though is already outside, so it's just negative 5. There's no need for it to change. Okay, so again, whatever's inside that you see for h, only for h, not for k, only for h, whatever number you see, it's always going to be the opposite. The actual value of it will be the opposite. So if you see x plus 3, that means that h is negative 3. If you see x minus, let's say 6, x minus 6, that means that h is positive 6, right? It changes signs when you pull it out. And k does not. K is whatever sign you see. So if you see negative 5 right there, it's negative 5 that you write right there. Okay? Those two numbers are pretty much your most important values that you're going to find, because it determines what we call the vertex of the graph. The vertex is the pointy end of the V shape. Here's the parent function. The vertex is 0, 0, the origin. When we do this right here, you have just changed the vertex to these two numbers. The vertex of our new graph is negative 3, negative 5. Let me repeat all that. For the parent function that we graphed here, the original, the vertex is 0, 0. Okay? There's nothing being added inside, there's nothing being added outside, it's 0, 0. But as soon as you start adding these parameters, that's what we call these h and k, these values right here. As soon as you start changing it with these parameters, the vertex moves to a new spot. It's determined by those two numbers. If h is negative 3 and k is negative 5, then the vertex is negative 3, negative 5. It's always h, k. Never flip them. Don't write k, h. Think of it also as alphabetical order. H is before k, so that one always goes first. So negative 3, negative 5 is your new vertex. That means that you can start graphing it already. Find negative 3, which is right here, and negative 5, whoops, never mind, which is right here, and then negative 5, which is down here. So this is your point right there. You could actually make a point right there to say that's going to be my vertex. I am sure of it because that's hk. And now you can start graphing it. It's going to look exactly like the parent function. I know that because there's nothing here in front of the absolute value. Okay? When there is something here in front of the absolute value, like a 2 or a 3, then it changes. It changes its shape. But since there's nothing there in front, I know that it looks exactly like the parent function. Okay, which means that I can follow the exact same pattern that I did for the parent function. From this point, which is the vertex, I'm going to go up 1 over 1, up 1 over 1, and so on to make my graph. And on the other side, I'm going to do the exact opposite, right? Up 1, left 1, up 1, left 1, so I could make the other side. So it's going to look like this. Up 1 over 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and so on. You could make more. That should be enough to draw an arrow there. And on the other side of the vertex, it's going to go up 1, left 1, up 1, left 1, and so on. So it's going to make that shape. And there you go. That is basically the exact same graph. It just got shifted all the way over here. The vertex is at a new spot, but it looks exactly the same. Let's answer the final three questions there. What is the slope of the left side of my graph? When I say slope of the left side, I mean of the new graph, the left side meaning before the vertex. So this part, what is the slope of this part? We've been practicing finding the slope easily by just counting squares. So just pick 2 points, let's say this one and this one, and find the slope. From here to here, the rise is minus 1, right? Negative 1, right there. And the run is 1. So the slope is negative 1. Now what is the slope of the right side? That means the right side of the vertex. From the vertex to the right, what is the slope of this part? Same idea. Pick 2 points, let's say from here to here. The rise is 1, the run is 1. So it's 1. Now it says describe the transformation from the parent function. Here's what I mean by that. Look at the original vertex, look at the final vertex, and tell me what happened to it. How did it change? Where did it go? I can easily see that from here to here, it went down 1, 2, 3, 4, 5, it went down 5, and it went to the left 1, 2, 3. Okay. We call those translations. When we move something, when we shift it in some direction, we call those translations. So this is a translation. This is what I want you guys to write. Down, how far down did we say? 5 units. And another translation, left 3 units. And you're done. Now that, if you notice, it says down 5 units and left 3 units. And if you look at our H and K values, it's left 3 units, down 5 units, negative and negative, because left and down. That's not a coincidence. That's going to happen every time. Okay, and we're going to practice trying to get this from just looking at those numbers in a little bit. For now, we're going to keep graphing it and seeing how it works out. All right, let's move on to number 2. Let's do it again. A little bit faster this time. Here we go. First, just like the last one, let's graph the parent function right away. So again, start at the origin, put a point there. Slope is 1 over 1 for the right side, right? Go up 1, right 1, up 1, right 1, and so on. And 1, left 1 on the right side. Up 1, left 1, up 1, left 1, and so on. Which means that the slope on the left side is -1. So it looks like that. There you go, there's the parent function. Now let's look at the other one, the one that they're giving me. Right here, find H and K. H is the homie inside. K has been kicked out. So H is in here. But remember what I said about H. When you pull it out to write it here, you gotta change the sign. So it's not -4, it is 4. +4. And K is the one that's been kicked out, which says 2 there. That one does not change. It's just 2. Do not change the sign of that one. Which means that the vertex comes from those two numbers. The vertex is 4, 2. Not 2, 4. Right? Make sure you always put H first. HK, 4, 2. So that means that I'm going to put a point at 4, 2 to start my graph. 4, 2, right here. That's your new vertex. Alright? Look again at right here in front of the absolute value. There's nothing there, right? If there's nothing there, that means that it looks exactly the same as this one. It's just been moved to a new spot, meaning that the slope is still going to be the same on both sides. Up 1 over 1, up 1 over 1, and then the exact opposite on the other side. If you see something there, then that changes, and I'll explain that later. But for now, since you see that there's nothing here in front of the absolute value, then it looks exactly the same. So make points that go up 1 over 1 for the right side. Up 1 over 1, and so on. This one is going to go off the page, but it keeps going that way. And on the left side, up 1, left 1. Up 1, left 1. Up 1, left 1, and so on. So it goes this way and this way. And there you go. That is the absolute value, absolute value function, but this one right here, not the parent function, which is the blue one. Alright, now looking at that, we can answer the questions. What is the slope of the left side? I think now you guys can see it. Since it's the exact same thing as the parent function, the left side right here, pick 2 points to find the slope, and there's no surprise. It's going to go down 1 over 1, so it's -1. The slope of the right side. On the right side, it goes up 1 over 1, so it's +1. And then describe the transformations from the parent function. The shape of the graph didn't change, right? It still looks like that V shape, but it moved somewhere new. So when you move, just look at the vertex. That's the only point that really tells you what happened to the movement. It moved to the right 4 units and up 2 units. We're not going to say move, we're going to use the correct mathematical term, which is translation. So it's a translation and we said right. It's going to the right. How many? 4 units. And another translation down, no, up 2 units. Could we have seen that without having to actually look at the graph? And the answer is yes. You could get this answer simply by looking here and saying, oh, H is 4, K is 2. H is going to move it to the right 4 units. K is going to move it up because it's positive 2 units. That's always always going to happen. We're going to practice that a little bit more in later problems, okay? But basically H will always move it horizontally, H horizontally. K will always move it vertically. So H will always be a horizontal movement, either to the right or to the left depending on the sign. K will always be a vertical movement, either up or down depending on the sign. Negative here will mean left, positive will mean right. Negative here will mean down, positive will mean up, every single time. Okay, at this point I want you guys to go to your side and attempt problems number 1 and number 2 on your own. Okay, so go ahead and try it on your own. Pause the video now so you guys can practice for a couple of minutes, let's say 3 minutes each, and then come back so you guys can see the graphed answer. Okay, so pause the video, take 3 minutes for each one, take a total of 6 minutes to try to attempt in both number 1 and number 2, then come back and see the answer. Okay, here are the correct answers for both of those. For number 1, you guys can see the graph right there. I graphed the parent function, and then this is my final one. What you care about here is that the vertex is -1, 2, because H is -1 and K is 2. And also it looks exactly the same as the parent function in terms of the slope, right? Up 1 over 1, up 1, left 1, because there's nothing here in front. The description is a translation. Remember, whenever we move something or we shift it, we call it a translation. It's a translation left 1 unit and up 2 units. You can see from the vertex here to here, it moved left 1 and up 2. For number 2, here is the graph. There's the parent function, there's the final one. The vertex is 3, 2 because H is 3 and K is 2. H is 3, not -3. Remember, when it's H, when it comes out, it becomes positive. It changes sign. So the vertex is 3, 2. And the description is a translation to the right 3 units and up 2 units. And again, also notice that the slope is the same as the parent function on both sides. Positive on that side and -1 on that side. It's exactly the same as the parent function. Alright, go back to my side, please, and let's work on number 3. Here we go. So it says, write an equation for each absolute value function whose graph is shown. Okay, so they gave us this graph right here, and they want us to come up with the equation ourselves, which is basically going backwards from the last problems, right? Instead of here's the equation, now graph it, it's here's the graph, what's the equation? First thing you do is look for H and K. H and K come from the vertex. So look at the vertex of this graph and figure out what the values there are. So what is this point right here? Be careful because this is going by 2's. So if this is 2 and this is 2, it'll be easier for us to tell. This vertex then is 2 for the x value. And the y value, I hope you guys can see it, that is right between 2 and 4. So it's 3. 2, 3. That means that H is 2 and K is 3. 2, 3. We can answer that question now. We can also answer this question. We already did. The vertex is 2, 3. What is the slope of the left side? Alright, let's try to figure this out. Let me zoom in again. The slope of the left side. What I need to find the slope is to pick another point so that I can make a slope triangle. This point right here is 0, 5, right? Because it's going by 2, so that's 2, 4, and that point is right between 4 and 6, so it's 0, 5. So I can tell pretty much by making a little slope triangle right here what the slope is. From here to here, it's going to go, it looks like it's going to go down 2, right, because this is 1 and this is another 1, that's 2, right also 2, because this is 2 right here. So 2 over 2, negative 2 over 2, I mean, because it's going down 2 over 2. That means that the slope is negative 2 over 2, which is negative 1. The slope on the right side seems to be the same except the opposite sign. From this point, let's say this point to this point right here, which is 4, 5. That's what that point is. That's 4, 5. I can go up 1, 2, and then right 2. Up 2, right 2. 2 over 2, which means that the slope there is 1. Alright, we're on track to find the equation. If we see that the slope on both the left and the right is 1, except on the left is negative, that means that my equation is going to look like this. Absolute value of something with nothing here in front. Because remember what I kept saying, if you see nothing there in front, that means that the slope is 1 and negative 1 because it looks just like the parent function, and that's what the parent function has. So now all I have to do is figure out what are the numbers that go in here. And we know them. They're h and k. H goes inside, k is outside. Let's put in k first, because k is the easiest. It's always going to be kicked out at the end, and it never changes signs. Whatever number you see here is what you put in there. Whatever number you see here is what you put here. But h is different, right? Remember I kept saying whatever number you see here, when it comes out, it becomes the opposite sign. So since this is the opposite sign of what was in there to begin with, that means that in here should be minus 2. That makes sense, right? Because when I take out the negative 2, it'll turn into positive 2. That's the only way that we could get this. And now you're done. That's what it's asking for. What's the equation of that absolute value graph? It's y equals absolute value of x minus 2 plus 3. Last is to describe the transformations. We're getting pretty good at that, I hope. It looks like it shifted from the parent function, which is not graphed. The parent function is not here. But you can tell from here, from these two numbers, what happened to it. Remember I kept saying h is horizontal movement. So it's a translation. H is a horizontal movement. That means translation. To the, what do you guys think? Left or right? Right. This one is a horizontal movement. That means left or right. If it's negative, it's left. If it's positive, it's right. So translation to the right, 2 units. And the k, which is 3, also makes a translation. And translation up 3 units. Why up? Because it's positive. If it was negative, it would mean down. So translation to the right 2 units and translation up 3 units. And that's it. You're done. Okay, one more, the last one on my side. Okay, let's work out through this one. It should be a little bit easier now that you've seen it done once. Okay, first I'm going to start by, I didn't do this in the last problem and I should have, writing what the equation should look like. And this comes from up here, right here on the essential question, is where you have y equals a times the absolute value of x minus h plus k. That's what the graphs of all of these are going to look like, what the equations are going to look like. I just wrote it like this without the a because I'm hoping that the slope is 1 and negative 1, so I don't have to write anything there. Okay. I think we're going to look at some problems that do have a different value here in the next day's lessons, but in today's they're all going to be 1s. I hope I put the correct one here. We'll check it just to make sure anyway. So it's going to have to look like that. So that means that I have to find the vertex. So let's find the vertex. It looks like the vertex is, this is also going by 2's. Okay, so make sure you guys are paying attention to that. That's a 2. That's 2. It looks like the vertex then is going to be 1, 3. Right here is 1, 3. And you know what, before I go back to write everything down, let's find the slope already, because they are asking us to find the slope on both the right side and the left side, right? So let's find the slope on the right side. Just pick 2 points, any 2 points. I'm going to use this one and this one right here. Right, from here to here, the slope. If I make a little triangle from here to here, the rise, which is the vertical movement, is 2. And the run is also 2. Right? Remember, these squares are going by 2's. So the slope is 2 over 2, which is 1. On the left side, pick 2 points on the left side. Doesn't matter which 2, just pick 2. I choose this one and this one. The rise from here, from this one to this one, remember, always from the left to the right. From this point to that point, the rise is down 2, minus 2. And the run is 2. So the slope is negative 2 over 2, which is negative 1. There you go. Now we can answer pretty much all of the questions. So h comes from the vertex, right? H is 1. H is from the vertex the first number. K is also from the vertex 3. Where is the vertex then? 1, 3. We already wrote that over there on the graph. What's the slope of the left side? We already found it. It's negative 1. What's the slope of the right side? Positive 1. That's good news, because if the slope of the left side is negative 1 and the right side is positive 1, meaning like that perfect slope, that means that you don't have to write anything here in front. All you have to worry about is plugging these numbers in the correct spot and you're done. So it's going to be y equals the absolute value of x minus h plus k. H, let's plug in the h. Don't forget, whatever you see here, it's the exact opposite in there. Whatever you see in here, it's the exact opposite outside. So what am I going to put in there? Minus 1. Right? Since this h is positive 1, in there it must be negative 1. That does not happen for k. K is already outside, so whatever you see here is the same thing there. That's positive, so it's plus 3. And that is the equation. That's what they wanted. The last thing we do is to describe it. Describe the transformations. So again, we don't have the parent function there to compare it to, but we have these two numbers, and that's enough to tell us what the transformations are. The first transformation is from h. H horizontal. That means left, right. If it's negative, left. If it's positive, right. So h is 1. That means translation to the right 1 unit. And k is 3. K is vertical, so that means up or down. Positive means up, negative means down. So in this one, it's a translation up 3 units. And done. Alright, I want you to go to your side now and try 3 and 4. So just like the last one, take about this one is going to take you a little longer than the last two. Let's take about 4 minutes for each one. Pause the video now so you can do it on your own. Please practice it on your own first and then come back and check the answer. Okay, so take a little bit of time to try them first on your own, then come back and check the answer. Pause the video now. Okay, here you go. These are the correct answers for number 3 and number 4 on your side. Zoom in right here real quick. On the first one, on number 3, h is negative 2 because of the vertex, right? I found the vertex and I noticed that it moves to the left. It's left 2 up 1, so negative 2, 1. So h is negative 2, k is 1, which is the vertex negative 2, 1. And so the equation is y equals absolute value of x plus 2. Notice what happens to the h. It's not negative 2 inside the absolute value. It's plus 2 plus 1 because of k right there. The description is it's a translation. That is the correct word to use. Translation left 2 units. How do I know that? From this, h equals -2. And up 1 unit from k equals +1. So again, h is horizontal. Negative means left, positive means right. K is vertical, vertical up or down. Negative means down, positive means up. Okay. You can also tell from looking at the graph, since the parent function always starts at the origin, it looks like it shifted left 2, up 1. Now let's look at number 4. Same idea. In this one, h is -1 and k is +1. Right? -1, +1 right there. The vertex is -1, 1. The equation is y equals absolute value of x plus 1. Once again, look at what happened to the h. It's not -1, it's +1 when it's inside of the absolute value in there. Plus 1. What is the description? Translation: left 1 unit. Left because h is negative. Negative means left, positive means down. And up 1 unit because k is positive. Alright, those are all the correct answers. You are responsible for this homework, which will be checked on Tuesday.